This is Paris, and I will be explaining the graph coloring problem using backtracking. So, given an undirected graph with n number of vertices, we have to color each vertex such that the color of two adjacent vertices should not be the same. This is the basic graph coloring problem that we are trying to solve using backtracking method. So, if for example we are given this graph with four vertices A, B, C, D, and the edges as AB, AD, BD, BC, and CD, we have to fill the graph in such a way that the color of A and B should not be the same. The color of A and D should not be the same. Similarly, with B vertex, the color of B and A should not be same. B and C should not be same. So for each vertex, the neighboring color should not be the same. We are given a subset of colors, that is R, G, and B, red, green, and blue. So we'll now try to solve the problem. In the first step, we fill the A vertex with red color. Moving on to step 2, that is vertex B, we cannot fill B with red as it would contradict with our condition. That's why we select B as green. When we go to step 3, that is vertex number C, we see that C cannot be filled with green but can be filled with red or blue. So we choose red. In step 4, that is the final step, we look at node D. Now, if we focus on node D, we can see that uh, D cannot be filled with red because the neighboring C is filled with red, and D can also not be filled with green because neighboring B is filled with green. That is why D is filled with blue. And this is one of the solution of graph coloring problem. Let us say this same approach through a state space tree. This is the final solution that we have come to, and this is the state space tree. So when we start from vertex A, we have three possibilities: either color A as red, or color A as green, or color A as blue. When we color A as red and move to the next vertex, that is B, we first color B with red. But this contradicts our condition that neighboring vertices should not be the same color. That's why we cross out B and prune this branch and color B as green. Then we move on to vertex C. Now we first color C with green, but this cannot be filled with green, so we prune this branch, we color C with red. Now from C, we move to D. For D, we first fill the color with red, and then we see that red is not fillable because D has a neighbor C, which is red colored. Then we also observe that D cannot be green colored because D has a neighbor B, which is green colored. So that is why we select D as blue. Through the state space tree, this is one of the solutions generated. There can be more solutions as well. You can just change the starting vertex color as green, then color B as red, then C as green, then D as blue. That is one solution, etc., etc. We get a very massive state space tree, and we can get all the possible solutions in this way. When we talk about time complexity of graph coloring algorithm, it is O of m to the power v, where m is the number of colors and v is the number of vertices in the graph. Thank you.